Hi everyone, and welcome back to another episode of Theory Thursdays with your favorite tutors at GetThere. Not too long ago, we shared a video of someone skipping a block of sodium across a lake and asked you guys to explain why it exploded into 1,000 tiny pieces. Today, we're going to answer that question by talking about chemical reactivity in the periodic table. The periodic table is brilliantly designed to help us understand the atomic structure of an element based on where it sits on the table, and therefore how the element will behave or react with other elements. Do you remember the Bohr model of an atom, which shows an element made up of protons, neutrons in the nucleus, surrounded by electrons arranged in shells expanding outwards? Well, in the periodic table, elements are arranged into vertical columns called groups, which tell us how many electrons are in the outermost shell of each atom. An element in group 1 would have 1 electron in its outer shell, compared with an element in group 7, which would have 7 electrons in its outer shell. Elements are also stacked into horizontal rows called periods, which tell us how many shells of electrons are surrounding the nucleus. Period 1 has 1 shell, period 2 has 2 shells, and so on and so forth. So, sodium, for example, because it's in group 1, has 1 electron in its outermost shell, and because it's in period 3, has 3 shells in total. Now, sodium is very reactive because it's quite easy for it to give up or lose the single electron in its outermost shell, especially because this lonely electron is also 3 entire shells away from the nucleus, meaning it's less strongly tied on by the electrostatic force of attraction from the proton. So, when you throw a block of sodium into the water, its atoms very quickly lose their outermost electrons and react with the hydroxide ions in the water, the OH in H2O, forming sodium hydroxide and hydrogen gas. The reaction gives off a lot of heat in the process, hence the big, dramatic, explosive display. What do you think would happen if you threw a block of potassium into a lake? Potassium is also in group 1, but it's 1 period below sodium, making it more reactive because its outermost electrons lie further away from the nucleus and are more quickly lost to reactions with other ions. This is why it's always important to wear the right protective gear in the lab. I hope you found this video helpful. Thank you again for watching Theory Thursdays at GetThere, and we'll see you next time.